Welcome. Today we're going to subtract rational expressions. From the homework, we'll be doing these 5 problems, one from each. Let's get started. So just like adding rational expressions, the first thing we need to find in order to subtract is a common denominator. And so in this problem, it's nice because it already has common denominators. Right, so we can just go ahead and combine our numerators and go ahead and just begin with the subtraction. So I'm going to write 8 minus. Now here's the trick. I'm not just subtracting x, so this would be incorrect. This implies only x is being subtracted, whereas x plus 10, the entire expression x plus 10 must be part of the subtraction. So you have to put parentheses after the minus sign. So that really what we're doing is we're distributing this negative. It's like a -1 that's being distributed in. So I'm really dealing with, so let's cross that out. That's wrong. 8 minus x minus 10. Now I'm showing that I've subtracted all of x plus 10. And this is all over x plus 1. We'll combine like terms. 8 minus 10. And then bringing down the negative x. So there you go. This is our final answer. Our excluded values we will get by setting our denominator equal to 0. So my only excluded value is going to be x cannot equal -1. Next problem. Okay, we need least common denominators, but right now I don't have it. So, if this guy has 3 times x and this one has a 6, then my least common denominator will have to be 6x. I can get 6x by multiplying this fraction on the left, top and bottom, by 2. I'm going to rewrite this actually. There's not enough room for me to do this problem right here. So I'm going to multiply the left guy by 2 over 2. Because that'll leave me with 2 parentheses x plus 1 all over 6x. So we have a common denominator there. Bringing down the minus sign. And then on the right, I can get 6x by multiplying top and bottom by x. So again, you need to keep in mind that we are going to distribute that x into both 2x and -4. So what I like to do all the time right away is just put in those parentheses around these little binomial expressions. Okay, so now I have minus, and I'm just going to put the x in front. 2x minus 4. All over 6 times x. So what I just did is I multiplied straight across here, and I multiplied straight across here, and so really this is what we're dealing with. Since I now have the common denominators that I need, I can go ahead and just combine my numerators at this point. So, write it in black. We have actually 2x plus 2. Is our first numerator. Now this minus sign gets grouped with the x. Remember, the minus sign has to be distributed, and so does the x. So we've got really minus x times 2x, which is minus 2x squared, and minus x times -4, which is plus 4x, all over 6x. So I could have gone straight from this step down to here. As long as you remember to distribute, that would be 2x plus 2, which is what I have right here. And then this would have given me -x times 2x. It's a little complicated, but yeah, -x times 2x would have been -2x squared, and then -x times -4 would have given me plus 4x. So you can write it out as a separate step or not. Just make sure you're distributing everything to those numerators. At this point, we can go ahead and combine our like terms. So, from the top, we've got -2x squared. And then I have 2x plus 4x, that's plus 6x, plus 2. all over 6x. So that would be a fine final answer, except actually we can factor something out of our numerator. And remember, before I told you that if you can factor and simplify, you must do so. And so what I can actually do right now is GCF. I can pull out a greatest common factor of 2 for my numerator. I'm left with negative x squared plus 3x plus 1 all over 6x. And now, since this is a factor and this is a factor, I can do that division. The 2 becomes a 1. The 6 becomes a 3. And my final answer is going to be negative x squared plus 3x plus 1 all over 3x. Let's look at our excluded values. So from the top, we should set our denominators equal to 0. So I get x cannot equal 0. And since there's no x down here, there is no excluded value. You can't set 6 equal to 0. That doesn't work. So our only excluded value is 0. All right, we're on number 3b now. Okay, let's find our least common denominator. So remember that these minus signs are acting, this minus and plus signs are acting like glue. We cannot just treat this 3 and this 6 on their own and look for their common factor. It's their least common denominator, the way we did here. Here, 3 and 6 were both on their own. They were both factors. So we could look at 3 and 6 and say, okay, 6 will be our least common factor, and what's left? An x. This is different though. Because they're attached with these plus and minus signs, we have to treat this as a unit, right? That's all one factor. We got to treat this as a unit. That's one factor. And since they have no factors in common, then we're going to make our least common denominator the product. Okay? So it's kind of like if I have 1 over 3 plus 1 over 5, my least common denominator, since they have nothing in common, is just 3 times 5, or 15. So you just multiply them together if they have nothing in common. That's what we're going to do here. So I recommend rewriting this so that you have enough room to work out the math, because we're going to need to multiply the left side, top and bottom, by the missing piece, which is x plus 6. And we're going to have to multiply top and bottom on the right side by the missing piece of x minus 3. So in our next step, we'll write our new common denominator. And now our numerator is going to be 2 times x plus 6. So we're going to do that multiplication first. Then we'll distribute negative 5, and we'll bring that down as well. Okay, so let's begin. We got to do, so there we go. Okay, so 2 times x is going to give me 2x plus 12. Now I'm going to distribute the minus 5 here. That's going to be minus 5x. And then minus 5 times negative 3 is plus 15. We're just going to combine our like terms now. Okay, got 2x minus 5x is negative 3x. Got plus 12 plus 15, that's plus 27. And our common denominators did not change. So what could we do here? We could pull out a 3 as the greatest common factor from the top. But if you do that, notice nothing is going to cancel. So while you could factor, it's not useful in this case because nothing's going to simplify. So this would be a good spot to stop right over here. Let's find our excluded values. So x cannot equal, well, what would make this equal to 0? It would be 3, so x cannot equal 3. What would make this equal to 0? Negative 6, so x cannot equal negative 6. That's our final answer. Moving on to number 4a. All right, we need to find least common denominators. However, we've got to factor first. So using magic X on the left side and magic X on the right side, go ahead and pause this video and factor the denominators yourself, rewriting it on the next step. Okay, so our least common denominator, we're going to get it by observing what these guys both have in common. They've both got an x plus 2 in common, so we definitely need that in our least common denominator. But then we have these leftovers, the x plus 3 and the x plus 2, so we'll bring those down as well. So our least common denominator, you could write it like this, or you could write it as x plus 2 squared, since it occurs twice, times x plus 3. The reason we actually need it twice is because it appears twice over here. And if this guy has 2 of it, then the other guy's going to need 2. And then on the left side, we have an x plus 3, so the guy on the right is going to need an x plus 3. So let's show how we get our least common denominator now. On the left, we need to multiply top and bottom by the missing piece, which is x plus 2. And on the right, we'll multiply top and bottom by x plus 3. So we've got a multiplication step on the left, and we also have to do the right side. So let's multiply. X times x gives me x squared. X times positive 2 gives me plus 2x. On the right, remember, we're distributing not just 2, but negative 2. Negative 2 times x is minus 2x. And negative 2 times 3 is minus 6. So, combining like terms, we see that 2x and negative 2x cancel. And we're left with x squared minus 6 as our numerator. Over, in my final step, I'm actually going to condense these into x plus 2 whole squared times x plus 3. This will be our final answer. Let's look at our excluded values. We're going to need to set our denominators equal to 0. So instead of looking here and setting it equal to 0 and solving, we've actually already factored. So we're going to look at our next step and set each factor equal to 0. So from this little piece, I get x cannot equal negative 2. And from this piece, negative 3. From these pieces, I get x cannot equal negative 2 again. So I don't need to rewrite it. But we do have 2 excluded values of negative 2 and negative 3. Okay, this is our final question. Number 5. Find the least common denominator. So this is like number 4 in the sense that we need to factor first. Okay. Go ahead and try it yourself. Try the factoring. So in the first problem, I can pull out a 3 using greatest common factor as my method. And in the second problem, I can pull out a 7. So what these guys have in common then is an x minus 4, which will definitely be part of my least common denominator. That'll take care of this and this. Now between the 3 and the 7, 3 doesn't go into 7. They have no factors in common. So then our least common denominator between those two is just multiplying them together. It's going to be 3 times 7, or 21. So it's going to be 21 parentheses x minus 4. Now to prove to myself that that really is the least common denominator, I have to show that I can multiply this into 21x minus 4. And I should show that I can multiply this into 21x minus 4. And I indeed can if I multiply this fraction by 3 over 3. And I indeed can on the left if I multiply it by 7 over 7. So there you go. I hope that this was helpful. Have a great day.